have a look at this next question, you really have to think it through, okay? For what values of b is the line y equals 12x plus b tangent to y equals x cubed? Now, I've talked before about the value of trying to get a picture in your head before you put pen to paper and start doing algebra, okay? So here's the picture in my head, right? I didn't draw this, as you can see. I really made it. This is the picture that was in my head, right? What's going on? Here's y equals x cubed, right? Now what they're asking you about is, and I've given you the language for this, right? Y equals 12x plus b is actually, in a way of thinking about it, it's a family of primitives. It's a bunch of lines that all differ by a constant. The b is just some number. That's why they say what values of b. And therefore, when you have a look at this, 12, that's a very steep gradient, okay? For instance, the gradient could be 12 over here, right? That would mean I get a tangent line, something like that, okay? Now, there will be a b that accords with that. It'll be up here, I guess, somewhere. But that is not the only tangent line that's in this family of primitives, that's off by a constant. If that's 12x, because x cubed is an odd function, I should be able to come over here and find a line that's exactly parallel. Wow, that's not bad. Anyway, and therefore also tangential to y equals x cubed. Okay? So therefore, before I put any algebra on the page, I'm expecting two answers because I look like I have two tangents. Okay? So then, I crunch the numbers and I see what happens. I've got two derivatives here. I mean, I know you didn't really need to work out this derivative, but I just did it for completeness' sake. And here's my argument. The lines are tangential, they're tangent to each other when their derivatives are equal. They share the same gradient, right? In other words, that equals that. 3x squared equals 12. I go ahead and solve, and as I was expecting, I have two answers that correspond to two lines. Now, I'm still not out of the woods yet. What do I do with these two answers? What have I just solved for?
The x value.
I have solved for the x values. Mark this. Pay close attention to this. I've solved for the x values where this guy and this guy are the same. Right? The x values. In other words, I have just found where is, see this y equals x cubed, right? I have found where is the gradient equal to 12, and the answer is at x equals negative 2, which is there, and at x equals 2, which, yeah, I don't know, use your imagination, okay? So at those two x values, that's what my equation is solved, right? You see how important it is to have put this line of argument here, right? So that I know when I get an answer at the end, what on earth does my answer mean? Because now I know where to put it, right? What am I after? I'm after b, aren't I, right? So in order to get, for example, let's look at this left-hand line. In order to find the value for b of this line, this is y equals 12x plus b, right? But it passes through, what is this point here? It's not just x equals minus 2. Can you see my argument, right? Over here, I've said y equals negative 8. How did I know that? Because I know it has to be tangential to the cubic curve, right? So the coordinates here are minus 2, minus 8, which means y equals 12x plus b has to pass through that point. So I substitute in, and I get a value for b. And then I rehearse the process, noticing that x equals 2. That's the point over here that's also tangential, right? And so therefore I put this into a different y equals 12x plus b, because I'll get a different b. Right? So you can see, like, if all you knew how to do was differentiate and say, okay, I get the answer out, you didn't get there, did you? Because, like, well, what do I do with my answer? You see the difference between, like, doing a process, I can differentiate, will be, I can solve an equation, will be, but now where do I go? Okay? So there's a big conceptual leap in these tiny little arrows here, right? To know, I better get some coordinates, because how else am I going to work out where b is? Okay? So don't fret if you're like, well, I just didn't know where to go there. There's a big challenge in this question, as simple as it sounds. Okay? So that's the way I thought through it. The rest of it's a little more straightforward, at least until we get to the parametrics. Yeah?
Isn't like tangent means that like you only tangent for one equals two lines, but you have to get at least tangent twice?
No. Okay, so there are a couple of problems here. So number one, what is the definition of a tangent? Our colloquial definition, which comes from circles, not from curves, our colloquial definition is intersects once. Because sure enough, on a circle, that's what it will do. Okay. However, it doesn't take that much imagination to realize if I give you like a graph like this, okay, and I say what is the tangent to the curve at this point? It's a stationary point. Okay. Tell me what you know about this tangent. If it's a stationary point. It must be horizontal, right? Clearly it must, well, that's terrible, sorry. Clearly it must be horizontal, okay? Well, if it's horizontal, you better bet your money it's going to hit the graph another time, okay? So therefore you see, hitting the graph once is actually not the definition of a tangent. The definition of a tangent is it shares the same gradient at the point of contact. So therefore that horizontal line I just drew is tangent to the curve. It's tangent here. It's obviously not tangent there. But I'm not interested in there, I'm interested in here, right? So it's not about do I hit once or twice. It's about do I share the same gradient. That's what's really going on, which is why I differentiate.